Hello everyone, hope you all are doing great. A very warm welcome to today's expert edge session on Introduction to Cloud Computing. I am Preeti, your host for the day, and I am absolutely delighted to have you all with us. Now it's my absolute pleasure to introduce our speaker, Mr. Akhil. Akhil is a dynamic and experienced trainer and consultant with nearly 17 years of expertise in cloud technology, specializing in AWS, Google Cloud, Microsoft Azure, and Alibaba Cloud. He has a proven track record in data engineering, generative AI, and cloud DevOps. Akhil is adept at delivering comprehensive training and consulting service that empower organizations to leverage cloud tech capabilities for digital transformation and operational efficiency. Over to you, Akhil.
Thanks, Preeti. Thanks for the introduction. And hi, guys. A very good afternoon to all of you. Thanks for joining in. This is Akhil Bangia, and I'm having around 18 years, approximately around 18 years of experience into various technology domains, primarily on cloud computing. And when we say from the cloud computing perspective, so I work as a consultant and a trainer on various different cloud computing platforms. That includes AWS, Google Cloud Platform, Microsoft Azure, Alibaba Cloud, and few more to name them. And other than that, I have done a lot of consulting projects for various different organizations in India, globally as well, mostly on cloud and the relevant technologies. So thanks for joining in. And this session, which we would be covering up today, I would be covering up mostly related to what exactly the cloud computing is all about. I'll be just talking about how the cloud computing works, how it is different from the rest of the other technologies. We'll be discussing about some of the benefits, some of even the drawbacks also of the cloud computing platforms. And then we'll talk about different type of services, service models, deployment models, and definitely there will be a practical. So I would be showing you how you can work on the cloud. Primarily, we will be taking up AWS, Amazon Web Services, as an example, and I would be creating a virtual server. On that virtual server, I'll be showing how we can connect to that virtual server, how we can host a simple applications, and with that, what all other additional things that we need to look after for making that application live in the production. So this would be the agenda of the entire session that we are going to conduct today. And I believe the audiences means some of you might be from a technical background, some of you would be working on the cloud computing also, and some of you would be completely new, let's say from the non-IT background also, who are eager to basically work on the cloud computing or want to switch over to this particular career. And that is a very great choice. You all know that the cloud computing is right now in the boom, and mostly almost all the organizations are these days using the cloud computing technologies for hosting their applications, for running their websites, even databases also. And there is almost a complete dependency on everything on the cloud computing platforms. So guys, I'm just going to share my screen and I'll go through a PowerPoint. And here I would be talking about mostly on what exactly the cloud computing is all about and how do you understand it. So I'll try to make it as basic as possible so that even those who are from the non-IT background, they should be able to understand the concepts. And I believe everyone can view my screen, right?
Yes, it is visible.
It's visible, right? Okay. So guys, when we talk about the cloud computing, in a very layman and in a very basic language, let's talk it about from the English perspective. And this particular word, cloud computing, we need to break it up into two parts. One is cloud, and the other one is computing. And that's the best way you can understand about this particular technology. So when we say computing, so what do you understand from computing? What does it come in your mind with respect to computing? Any device that can or that has the capability for the computational task, that is what is called as computing, right? And you may think of a calculator, which is the simplest computing device. Why? because it has the computational capacity. You just put up any number and it gives you the output. Then, if we move it further and we elaborate it from the computing perspective, then we can talk about the laptops, desktops, your mobile phones. All of these are what? Computing devices. Why? Because they can execute the instructions. How these devices are considered as computing? Because they have certain resources, some technical resources that make them an kind of an intelligent device that can take up the instructions and execute them accordingly. For example, if I talk about your systems, your desktops and laptops, so they have a processor, right? They have a random access memory. They have the storages or the hard disk. All of these combined together makes that laptop a computing device because it has the power of doing the calculations. Now, if we take it more further and elaborate it from the company's perspective, enterprise perspective, what happens in the organizations, then the, the companies are having their own data centers. And the data centers are the places where they keep all their computing devices stacked together. And what are those computing devices? Those computing devices are mostly related to servers, which are large computers only, storage devices, you have routers, switches, you have firewalls, and many other equipments. All of them are stacked together. So a basic or a simple data center would have a lot of servers, all these computing devices stacked together. And when we make these computing devices available on the network to be accessed remotely, that is what is called as the cloud. So cloud is a network or the collection of all these computing devices that can be accessed remotely, either through the internet or through any other network as well. So together it combines the platform which is called as the cloud computing. Now to understand that in more example perspective, let's assume right now we are conducting our session on Zoom conference platform. So Zoom conference is an intermediate, and through that I am sharing my screen. Now obviously I'm sharing my laptop screen. I can give the access of my laptop to any one of you, and you can take the control of my system, my Windows operating system. You can even take the usage of my laptop storages, but you don't own them. You are accessing it remotely over the internet. How? Using a Zoom conference platform. So, in a very layman or in a very niche segment, I also become a cloud computing service provider for you because I am giving my computing resources to someone who can access it remotely. That is what these cloud computing platforms or this is these cloud computing companies what they are doing. For example, Amazon Web Services, Google Cloud, Microsoft Azure, they are having their big data centers which are spread across various different locations, different continents. All of them are interconnected together, and using an APIs or using some virtualization technologies, they are giving the access of that infrastructure to us, which we can access it remotely over the internet. So ideally, the cloud computing is nothing but it's a platform, and we are accessing someone's else server, someone's else computer remotely over the internet only. All right. Now, why do we require cloud computing, or what is the purpose of using the cloud computing? Let's say this is a very simple concept. Means anyone can share the access of their servers remotely over the internet. But what is the need of it? Why do we need the cloud computing these days? See, think from the organization's perspective. Let's say there are financial firms, there are marketing firms, there are non-technical firms, and these days you know that in order to run any kind of a business, any kind of an enterprise, there is a lot of dependency on the technologies. And let's assume that these organizations, if they have to set up their applications, if they have to set up their softwares, their technological related infrastructure, so they have to set up entire data center on their own. They have to first procure the servers from the market. They have to procure all these storage devices. Then also to set it up, they need a real estate, a facility where they can set up all that infrastructure. They require human resources. Different teams would be needed to work on these particular infrastructure, and it takes a lot of time to create the own data center. It may take around 6 months, it may take around 1 year, 1.5 years, likewise. And just think about that, a non-IT firm or a non-technical firm, why would they spend that much amount of money in these things, which is not their core functionalities? Why don't they outsource it? So when the cloud computing came, these organizations who are providing the cloud computing platforms, they said that we are having a global infrastructure, global data centers, and we have incorporated millions of servers in our data centers. All of them are up to date, upgraded, latest infrastructure, you get it. And what you need is, you don't own them, you just have to access it remotely by having a good internet connection. You need to create an account. Once you create an account, you would be able to access the enormous global infrastructure that is spread across the world in various different continents. So the organizations will think that, yeah, that's a good thing, and probably means it saves a lot of time, it saves a lot of effort, even the cost is also saved a lot, and they can reach out their products to the market very quickly by experimenting them on these cloud computing platforms. So with that, the technical infrastructure need is reduced, and the organizations can now outsource that particular, if they have to, let's say, host their applications, or if they have to create a databases, they can do that quickly on the cloud computing platforms, and even without owning that infrastructure. Even the best thing is that they just have to pay for whatever the time they are going to use these resources. Let's say, for example, if we have to create, if we need an access of a server. Why? Because let's say we want to host our software or deploy our software or an application. What we'll do, we have the AWS with us, we have the cloud computing platform. Quickly, we will log in into it, and then we will create a virtual server, test our application. If everything is fine, we'll roll it out to the production. And it will take not more than 1 hour if everything is in place. And just imagine if this is something which you have to do it yourself. So you would go to the market, you will first purchase a server. What would be the capacity of a server? You would decide it. There will be a one-time cost that needs to be put it up. And then you're going to do the virtualization of that server. You are going to install the operating system, and lot many things that needs to be done. It will consume a lot of time. It may take months time or even a year's time to get your applications or softwares rolled out. So you save, the organizations, or if an individual, they can save a lot of money, time. They get the latest infrastructure, the updated infrastructure, and they have to pay only for the time and the duration that they are going to use these particular resources, which we call it as the on demand paying. So that is the reason that there were so many advantages the cloud computing offered. And if I keep on talking about the cloud computing advantages, it will take a lot of time. And that's the reason that almost means most of the Fortune 500 organizations, some big organizations, they have already migrated their environments on the cloud. A lot of mobile applications, or the applications that we are using on a day-to-day basis, they are also on the cloud. For example, let's say Amazon Prime, everyone uses it, right, for watching up the videos and all. Netflix, Spotify, and to name many other mobile applications, Swiggy, Zomato, all of them are mostly in the back end, running their applications on the cloud computing platform. So ideally, these organizations are not owning that infrastructure, they have outsourced their technology on the cloud platforms. So that builds up a lot of trust for using these platforms. And since big organizations have migrated on the cloud, that would be followed by the rest of the other organization. And that is the reason that there is so much need and the demand for the cloud computing environments. Now, with the cloud computing, we have discussed about the advantages of the cloud computing. Uh, I would not say that almost all of the things are good here. Means everything is an advantage in the cloud computing. Definitely, there are some disadvantages also. Each and every technology has pros and cons. Some disadvantages you may find in the cloud computing as well, like there could be compliance related issues, some laws that needs to be followed up. Along with that, the availability of the infrastructure, availability of the services, the location that needs to be decided. For example, if I talk about Amazon Web Services, So in AWS, you have in India, you have only two locations that you can select, either Mumbai or Hyderabad. You don't have a flexibility to select any other location. Let's say if you want to set up your data center in Delhi, so that is something which you cannot do that on the AWS cloud. You have only either Mumbai or you have it in Hyderabad. However, there are ways that we can optimize it, but directly we cannot do that, right? Along with that, means most of you, or even whenever I take up the sessions or discuss about the disadvantages of the cloud computing, everyone talks about that security could be a challenge, right? So you guys also must be thinking that the cloud computing is not that secure as compared to having the own data centers. And I think all these big organizations have taken it up seriously, and they have implemented a lot of security measures these days. A lot of multi-layer securities has been implemented on the cloud. And when we talk about the security, actually, let's say we have to understand the shared responsibilities here. It is not that everything the cloud is going to own and should be responsible for that. When we deploy our projects, when we deploy our architectures on the cloud, how we are going to deploy them, how we are going to configure them, whether we are following the best practices or not, that are defined by the cloud. If there are gaps in it, definitely there are going to be hacks or leakages of data that could happen. So the best practices needs to be followed up. The well architected framework needs to be followed up, and you need to understand what are the shared responsibilities, how much responsibilities the cloud owns, how much responsibility we own. And then if we follow all these guidelines, then we can say that yes, the cloud is very much secure as well. Okay. So from the disadvantages perspective, not much disadvantages as compared to having the features and the advantages. And that is the reason that so many organizations are nowadays depending on the cloud computing environments. Now, what do you think? What are the various different cloud computing providers in the market these days? Any famous one that you can name? Probably you can put it up in the chat windows also. Let me see what messages I get. Just a minute. So, what do you think? Which is the popular cloud computing provider right now? AWS. Yes, absolutely correct. AWS is there. Google Cloud is there. IBM is there. Microsoft Azure is there. Absolutely correct. Alibaba Cloud, the Chinese cloud. Yes, that is also very good. And then there are cloud providers which are in the niche segment also. They are working in a specific segments as well. But when we talk about the big cloud providers, definitely Amazon Web Services is the one that comes up. Why? Because they pioneered this concept. This cloud computing was more popularized by the Amazon Web Services, right? Snowflake, yes, good. Okay. So we have a competition with AWS as MS Azure. Microsoft Azure is there. We have Google Cloud Platform, and then Oracle is there. Oracle Cloud is there these days. VMware Cloud has come up in the market as well. Now, guys, whenever you work on any of the cloud computing platforms, um, you cannot see you are working on someone's else infrastructure remotely. So directly, you don't own the hardware. You cannot have the direct access of a hardware. So how that company is going to provide you the access of their hardware using a technique that is a virtualization technique. So what these cloud computing providers have done is they have used a virtualization technique in their data centers at their locations, and they have linked it with some sort of a applications which you can understand it in the form of an APIs also. And in the form of services, they are giving the access of their infrastructure. So what, as a user, as a cloud user, what I need to do it or what you have to do it, you don't have to understand how their infrastructure is located, where exactly they have placed their infrastructure or the hardwares. We have to understand that whatever services they are offering us, how to work on them and how we can use those services in our projects so that we can get the outcome for the organizations. Or if let's say I am planning to deploy my project only itself, so what all things I can, or what all services I can use with the cloud, with which I can get a better outcome. And that is the reason that whenever we work on the cloud computing, we have to thoroughly understand what exactly the service models are all about. Okay. So these days, as I mentioned, that there are big cloud providers and there are medium scale cloud providers and those who are working in a niche segment also, let's say in a specific segment as well. So there are bifurcations of various different service models, but primarily we have to understand three types of service models. And before I start up with the explanation of these service models, we need to understand what exactly the service model is all about. So when we talk about the service models in the cloud computing, which is a very generic concept, it means that how the cloud computing provider, for example, Amazon Web Services or Microsoft Azure, how they are providing the access of services to us, how we can how we can use them, how we can access them. That is what the service models are. And once we identify each and every service in which category it lies, then we can match it with our project, and accordingly we can select and choose which service we should work on. So as an architect, as a cloud engineer, as a cloud administrator, you need to understand the service models. You need to understand that where exactly those service models fit in your projects, and accordingly you can choose and select the services offered by these cloud providers. Guys, when we talk about AWS or Microsoft Azure, these kind of a cloud providers are so massive that they are providing more than 200 plus services, and almost any technology you can run on these platforms, be it IoT, be it artificial intelligence, be it data analytics, be it compute, be it storage, be it database, whatever you can think, mostly you can get it run on these platforms. And which service to select, that is something which we need to decide. So when we work on the services model, primarily the categorization, the three main categorizations are infrastructure as a service, then you have a platform as a service, and the third one is the software as a service. Okay. And these three service models, once you understand that, then it will be easier for you to work on the cloud. Whether you work on AWS or Azure, it will be very easy for you. And when we talk about the infrastructure as a service, it means the cloud computing provider is going to provide us the access of their infrastructure at the best possible way in this infrastructure as a service format. Okay. This is used in case, let's say, if you're planning to have a server. So you would go to AWS and you will look for a service which is under the category of IaaS, and accordingly you will select it and you will create a server for that. All right. So infrastructure as a services only gives you a raw infrastructure, a raw hardware in the virtualization format, which you can call it as a virtual machines also. Some people call it as EC2 instances when they work on the AWS, or you can call it as a virtual servers. With that, you can get the operating systems deployed on those virtual servers. Like you can get a Windows operating system, you can have a Linux operating system, and then you get an access of that server entirely. It is up to you what you want to do with that server. You can host an application, an HTML application, a PHP application. You can install some Java runtime environments, put up or upload Java codes. Even you can create the databases, SQL databases or no SQL databases, whatever you want to do. You just get the infrastructure, and it is up to your knowledge, your technological expertise. On that basis, you are going to work on these particular servers. So that is why it says infrastructure as a service. That means they're going to give you the access of their infrastructure in the form of the services. Now, what are the benefits of using these kind of a services on the cloud? Let me see what all messages I get. What are the benefits of using the infrastructure as a services? What do you think? Yeah, Geo is also launching, right? Right, correct. Salesforce is there, Oracle is there, correct. Good. Now, anyone who can just put, what do you think? What would be the benefit of an infrastructure as a services? See, first of all, cost effective. Yes, very good. Infrastructure as services are the most cost-effective way of working on the cloud. Let's say if I create an virtual machine or a virtual server on the AWS cloud, I get a full access of it, and over that I need to customize it. So cloud responsibilities are less. Cloud is just going to create a virtual server, get me an operating system installed. That's it. So their responsibilities are less. They are going to charge us less. Anything which we manage less, definitely we will bill the customers less also. Anything which we are responsible much, we will charge that as well. So in the infrastructure as a services, cloud's responsibilities are very less. They just have to get the virtual machines created and give us the access in the form of an IP addresses. And hence they are the cheapest way of working on the cloud platforms. Let's say if you're a technological expert, a database expert, you just quickly get a virtual machine created, get your database engines installed, and start adding the data. That's it. It's done. You can link them with the applications, whatever you want, you can customize. So some of the examples with respect to the infrastructure as a services, on the AWS, on the Amazon Web Services, there is one service called EC2, that is called as Elastic Cloud Compute, which is a perfect example of an infrastructure as services. And you know that this is the widely used service on the cloud as well. Anyone who has started working on the AWS, I'm sure they are going to start working on the EC2 first. Because a lot of things you can do it from the EC2. Almost anything you can do it with the EC2. It gives you the access of the computing things of the cloud. Same thing on the Microsoft Azure. The service name is different. The working way is a bit different, but actually the outcome is same. So on the Microsoft Azure, you get it virtual machines. On Google Cloud, it is called as compute engine. And all of these are the examples of infrastructure as a service, right? Guys, if you know any of the cloud, and that's from my experience, like if you know to how to work on AWS or Azure or GCP, then it becomes easier for you to work on the other cloud platforms also, because the concepts are almost similar, just that the platforms, the naming conventions are a bit different. And definitely there are some differences in the global architectures as well. Anyone having any doubts, any queries? Cost effective, capital expenditure is less, pay only for what you see. Good. uh, all right, yeah, these are some of the examples, correct. Now this is hard to understand. Those who are new on the cloud probably may struggle to understand that, but I'll try to make it as easier as possible. So what do you mean by a platform as a services? Platform as a services means that the platform is readily available on the cloud. This is for those, this is an advantage for those who are basically working in the development industry, those who are coders, those who are working in the software industry and not from the infrastructure background. For them, the platform as a service is an advantage. On the cloud, like AWS, there are so many services which lies in the category of PaaS model. Now, what do you understand from a platform as a services? That the cloud ensures that the platform is readily available to be used, which means that you don't have to get the infrastructure or a virtual server or a virtual machine created on your own. It is something which the cloud is going to manage it in the backend. Along with that, the cloud will also ensure the proper operating system is installed and the proper runtime and a middleware is also installed on which you have coded. Let's say you want to run a PHP code. So the cloud will ensure the PHP runtime environment is already ready. The platform is ready. You just need to upload your code and the cloud is going to deploy that code for you in the backend. Definitely, they will use the servers in the backend, the hardwares in the backend, but that is something which we do not have to take care. We do not have to take care of the networking part of it. We don't have to do the load balancing. We don't have to focus more on backups, upgrades. All of these things will be taken care by the cloud provider. What we need to ensure is, or what we need to focus more on is the code is proper. Our applications are properly designed. So that is what the platform as a services are. In this kind of a services, Most of the responsibilities the cloud takes, and the development activities and their responsibilities are taken by the end user like us. And hence, you will find that most of the platform as a services are chargeable. Even some of them are quite expensive also. All right. To name few of them, some of the examples, let's say on the AWS, there is a service called RDS. Has anyone heard about RDS? Relational Database Services. It is primarily used for creating a databases, right? Okay, great. So relational database service, you know that if you have worked it, you know that it is a very expensive service. Though now on the AWS RDS free tier options are also available. But if you create a database from the enterprise level perspective, you may expect a lot of, means a huge billing that may happen at the end of the month. The reason is obvious. There are license costs, a lot of things that the cloud is managing for you, backups, snapshots, redundancy, auto failovers, upgrades, schedule maintenances. All these things will be taken care by the cloud. You don't have to worry about it. What you have to worry about is how you are going to add the data, the database tables that you need to create. That's it. How you are going to integrate it with your apps. Okay. Then there are other examples like on the AWS, if I have to take it up, then you have a service called Elastic Beanstalk, which is also an example of platform as a service. Elastic Container Services, Kubernetes service, which is popular in Google Cloud and Microsoft Azure, and even in the AWS. Cloud Formation is also one of the examples of the platform as a services, though it lies in furthermore categories of the service model. Likewise. So that was from the past services, guys. And the third type of a service model that we are going to discuss is the software as the services. Now, what happens in the case of software as a services? As the name suggests, software as a service means the software is readily available. Even we don't have to code for the software. Unlike in the case of PaaS, in the PaaS, you have to develop a code. You have to write it. A Python code, you have to write it. But in the SaaS or in the software as a services, even we do not have to write a code as well. We just have to subscribe to the software or its features and start using it. It is on a subscription basis. Now, who has deployed that software? Already it is existing on the cloud. On the AWS, on the Google Cloud, the software is readily available. We just open up through the link, put our mail IDs, sign up, and start using the features and the subscriptions of the software. Many examples on a day-to-day basis, we are using software as a services. A lot of mobile applications that we are using, Netflix, we have to subscribe and start using its features, right? When we order anything from Zomato, software as a services. All CRM tools, customer relation management tools, Zoho CRM, Salesforce, all these are what? We don't do any kind of a development activities until unless we are going to integrate it. Everything is readily available. We just have to use its features. Where exactly they are hosted, we are not aware. On which coding language they have been coded, we are not aware. What middleware is being used, we don't know. What type of an operating system is used, we don't know. It is just that we are accessing the software and using its features. So in the software as a services, hardly we have to do it. We just have to accommodate in our project architecture and use it efficiently. All right, guys. So these are the three main service models that we need to understand. And from these three service models, there are further more service models that comes up, which are further, you can say, the bifurcation of these service models only. And these are used by the niche cloud providers in the market. So you have a function as a service, you have an infrastructure as a code service, storage as a services. Where exactly you can use storage as a services like Google Drive. Google Drive is what? It's a cloud, right? It's a kind of a cloud storage only, but it gives you only a particular functionality, a particular feature, that is the storage as a service only. Okay. So that was from the service models, and then comes the deployment models also. And this is also something which we need to understand that. And once we understand the concept of a deployment models, then we'll take up a particular cloud. We'll understand its global architecture. And with that, we will do some practicals also. Okay. Now, what exactly the deployment model is all about? First of all, guys, whenever you work on the cloud, generally there are two types of cloud that you work. One is a public cloud, and the other one is the private cloud. All right. Public cloud, the names that I've been taking, like AWS, Azure, and all, they are public clouds. How? Because anyone can create an account on these clouds. You just need to have a mail ID. You just need to have a personal mail ID, a credit or the debit card, and you can easily create an account on these platforms. Anytime, anyone, even a child can also create an account on the AWS. Just they do not they require the credit or the debit cards, authenticated one, and even the enterprises also they can use the public clouds. No restrictions. There are clouds which are working in a private cloud space where they only provide you the access if you are having a contract with them. They are mostly into B2B segments or enterprise to enterprise segments. A lot of examples you can have it. IBM has a private cloud. They have a public cloud also. Then Cisco has a private cloud. Oracle and VMware, they are also in having public and the private both. So these are some of the examples related to the private cloud. If I have to create an account on them, I need to have a contract with the cloud provider. I have to purchase the licenses. Else, I would not be able to create an account and start using their services. Okay. So obviously, the public clouds are widely used because they are easy to access. Anyone can create an account. All right. Now, when we talk about the deployment models on the cloud computing, we are not considering about how we are going to access the cloud. What we are considering here is how we are going to deploy our projects, our solutions on the cloud. First of all, the deployment model means that how we as an end user or the cloud users are going to use the cloud services for our benefits. How we are going to deploy our projects on the cloud. That is what the deployment models are generally. And you can deploy these solutions in various ways. You can do a public cloud deployment. Anything that you deploy on the cloud, which is available on the internet, publicly available, that will be considered as a public cloud deployment. Let's say the perfect example is going to be if you deploy a website on the cloud. Let's say if you plan to host a website on the cloud, you would not restrict it from the internet, right? Anyone should be able to access it. Let's say if I'm planning a website with the name www.abcd.com, for example. So I would not restrict the access of it. I would say that, okay, it should be available globally. Everyone should be able to access it. So what kind of a deployment it is? It is a public kind of a deployment, a public cloud kind of a deployment, right? The private cloud of deployment, what does it mean? Anything that we deploy on the cloud which is completely isolated from the network. Nobody knows the existence of it, and nobody should be able to access it easily. That is what is called as a private cloud kind of a deployment. Now, what you can deploy as a private cloud deployment? I have given an example of a website which can be deployed as a public cloud deployment. What you can deploy it, which would be completely isolated from the internet. Internal apps, very good. Yes. What else? Your backend applications, your backend microservices, or those who are not that technical, your databases. Would you uh, would you create a database which should be available on the internet, accessible for everyone? Yes or no? You won't do that, right? No. So a company would try to restrict the databases because they have a critical information. So how you're going to deploy the database? You would try to do the deployment of a database in a private cloud kind of an environment where the access is restricted. Only the administrators would have an access. Only the database administrators would have an access. Anyone would not know the existence of it, or they would be completely not available on the internet. We will restrict the public IPs. Only the private IPs will be allocated. We will restrict all the ports. So these are some ways that we can do the private cloud kind of a deployment. So one example of a public cloud deployment is going to be the websites. that we are going to deploy it on the cloud. The other example is of a private cloud deployment is going to be a database, internal apps, backend applications, where we can take the full control how the access should be given. All right. The third type of a deployment, which is widely used in any kind of a project, is called as a hybrid cloud deployment. And it has multiple definitions also. The easiest way to understand the hybrid cloud deployment is the combinations of a private cloud and the public cloud. That means when you combine the private and the public cloud deployments together, then you get the hybrid cloud deployment. That means you have created a project in a hybrid cloud environment. Now, how you can relate it with the real time scenarios, with the practical scenarios? For example, in the public cloud, we deploy a website. In the private cloud deployment, we deploy a database and integrate it together. Website needs to be integrated with the backend database. Otherwise, how the inquiries, how the information will be reflected on the website. All right. So we are in the backend combining the public cloud as well as the private cloud deployments together. And that entire architecture will be considered as a hybrid cloud deployment. That becomes one example. Then this kind of a deployment, when we do it on a single cloud, let's say on AWS, it is called as a cloud native hybrid deployment. Okay. The other definition could be there are some organizations, they may think that let's try to move our applications, our front end applications, our websites on the cloud because they are that is a cheaper option. But we are not very much sure about the security of the cloud. We are not sure how secure the cloud is going to be. So we will keep the database with ourselves. We'll not move it or migrate it on the cloud. We have a database server at our premises, so we'll keep it here. But all your websites, all our front end environment, we will migrate it on the cloud. And this way we can save a lot of cost. So whenever this migration happens on the cloud, all these web servers needs to be integrated with the database that we have kept it in our data center at our location. And when we integrate it together, the on-premises or our data center plus the cloud deployments, when we integrate it together, that is also an example of a hybrid deployment. But that is not a fully a cloud native approach. Is it clear, everyone? This becomes another example of a hybrid cloud, which is a bit complicated kind of or a complex to understand for the beginners. But those who have some understanding of the cloud, they should be able to understand it. Even from the hybrid cloud perspective, it is not necessary that I have to select always the AWS. I may select AWS combo clouds also. I may select AWS plus GCP, AWS plus Azure as well. It could be a possibility, let's say, when we do a cost estimate and we find that there are some services of an AWS which are cheaper, which are good, but Microsoft Azure provides some services which are very good. Let's say from the Microsoft products perspective, from their software's perspective. Let's say Active Directories, if we have to use it, we will prefer to use Azure for that. They have a very big kind of an intra ID kind of a functionalities. Google Cloud, they provide a lot of PaaS services, which are very good. Like Google App Engine is there, Google Kubernetes is there. Very much a recommended kind of services. So why would I only, or the organization is only going to depend completely on the AWS in that case? They may take the best of the services of each of the cloud and integrate it together. So that integration will be also an example of a hybrid cloud. So combo of AWS plus GCP would be considered as a hybrid cloud kind of a deployment. All right. So will we provide a certificate? Okay, Ganpati is asking, and this is something which Preeti can answer.
Yeah, currently for the
I'll
session,
just
we are
take it.
not providing.
Yes.
Actually, we have like around seven questions with us. Like,
Okay.
I can read it for you.
No, I'll just take it up. No worries. So let's take up some questions. What about of data and GDPR? They are all related to security parameters, and they are implemented very good on the cloud. Specifically, when we talk about the AWS and these kind of big clouds, they take up a lot of compliance related things very well. Okay. Well, cloud computing makes data analytics complex and makes process of extracting valuable information difficult and big challenges to data science. No, absolutely not. You will see that these days a lot of projects are being running on the cloud. They provide you a lot of services where you can use data analytics. You have the availability of data sciences as well. ETL processes are very much easier nowadays on the cloud, and means it has actually made it very easier for the people to actually work on these kind of technologies. Just imagine that data sciences, data analytics, machine learning, AI, if we have to run them, these kind of technologies, it takes up a lot of computing resources. So it will be very difficult for us to practice on our own servers, on our own premises. We have to take up big computing servers. Even GPUs might be required, which are very expensive. The cloud gives you readily available. So it is easier actually to work on these technologies on the cloud because these infrastructure related things are readily available. Let's say if you're planning to create a machine learning model, so you have so many services on AWS and the other clouds that you can quickly run it, and then accordingly whatever things that you want to get it created, you can quickly get it created. Even you get the samples also. AWS SageMaker, which is one of the popular service for the machine learning. You have Glue, AWS Glue for data analytics. You have Prometheus, Grafana for reportings, right? You have ETL processes, EMR, Elastic Map Reduce there, which you can use it for data analytics and data sciences. So that makes it actually easier to work on these technologies. What is the difference between a public and a private cloud? I have answered that. The public cloud is the one which can be on that the account can be created by anyone. You can access it. Even the company can create their account. Even an individual can create an account and work on it. Private cloud is restricted. It is business to business or B2B, company to company. Let's say a company A has a contract with a cloud provider. All those staff members of company A should be able to access that cloud. But anyone who is not part of that company should not be able to access that particular cloud. So that is what the private cloud is restricted. Then we got another question, which is what about the backup? Is the server okay, let me read it. What about the backup? Is the server is fires or crashed or some bomb attack on it? That is see, that can happen anywhere, even in the data in your data center also. Okay. See, if you there are a lot of videos on YouTube, and just go to the YouTube and search for AWS data center or Google Cloud data center, and you will see that there are so many security layers they have added. Uh, Before the core layer, there are too many security layers they have added. There is a lot of securities. Perimeter layer is there. Everywhere the cameras are, fire extinguishers are, and then you have power backups. And nowadays they say that very less carbon emission. They are more green kind of a data centers also. So I don't think that is going to happen. And if a server crashes, there are a lot of ways you can do the redundancy, and that is the cloud is famous for. Uh, because these things are very much difficult to achieve in your own data center at your places, but in the cloud you can easily achieve them. The backups, the servers if they crashes, how to recover the data, how to plan a redundancy, even a business continuity plan or a disaster recovery. The one that you have said is crashed or some bomb attack happens, that is actually an example of a disaster recovery, which is called as DR. Anything can happen. Let's say there could be a cyclone, there could be a kind of natural kind of a disaster also. In that case, what would happen? You have other locations. We have Mumbai, we have Hyderabad on AWS, then we have US, Ohio is there. We have a lot of regions in Europe also. Singapore is there. So you can plan the redundancy accordingly because it's a global infrastructure that you get an access. And the good thing is, whenever you plan a BCP, or business continuity plan, and the DRs on the cloud, it is very cheaper as compared to setting up in their data center. Almost companies, we have seen in the case studies that companies have saved more than 80 to 90% cost in setting up the business continuity and the DRs on the cloud. Okay, that is one of the advantage of actually using the cloud. Then we got another question, which is which one is secure for database? Which one is easy to use? Or so many cloud service providers in the market. See, I would say that you go with whatever the famous ones are, because they are trusted cloud providers, and they give you the data availability somewhere close to 99.999 recurring percent of assurance, which means that out of 365 days in a year, most likely there is going to be one outage, and that is also for few hours. That is what you can expect, and rest of the time they will ensure that your servers, your databases will be kept running. So these are very trustable cloud providers. But if you want to go with some cheaper options, then you have a lot of cloud providers in the market that you can go with that as well. Is hybrid the most expensive? Not necessary. It may be a cheaper also. It is the smart way that you're going to deploy your architects. And that is the reason that you need to have a proper understanding of the cloud. And hybrid is actually going to save a lot of cost. Because if we don't know about multiple clouds or multiple technologies, then we won't be able to create the hybrid. All right. So hybrid is not expensive. Hybrid can be a cheaper option if it is implemented efficiently. See, for example, if AWS gives me a database service, which is expensive, I know, then I may prefer to use any other cloud. And this way, I can create a hybrid architecture. Yeah, Preeti, if you want to answer that question, let me know. You want to answer that question, Preeti?
Which, sir, regarding certificate?
No, is hybrid the most expensive? I got the message. Preeti would like to answer this question.
No.
Okay, no worries. Then there is another question where the large scope of opportunities lies in which cloud type in next 5 years. See, I would find it more in the public cloud because it is easily accessible. Everyone can access it. There are no restrictions. So more user base is going to be on the public cloud. Um, I don't think the private cloud is going to be that big, and that's the reason that IBM started up with the private cloud. A lot of other companies started up with the private cloud, and now they are moving into the public cloud space because they know that the user base is more in the public cloud. See, if you plan to work on the cloud, what you can do, you can quickly explore any of the public cloud and quickly create an account. So for the cloud provider, another user is added, and that increases their demand and the requirement automatically. Which certification will be valuable in market? I want to certify it in AWS. Please, can you suggest? Uh, you may go with the AWS Solution Architect Associate if you have some experience in the technology, not only on the cloud, but any technology. But those who are freshers, those who are college students or just passed out, they should go for AWS Cloud Practitioner. That gives you the basic understanding of the AWS cloud. How do you work on it? But those who are having some years of experience, whether you are working in the web technology, whether you are working in databases, whether you are working in the infrastructure or networking, you should opt for the AWS Solution Architect Associate, because that gives you the complete understanding of all the AWS essential services that are required to build up any project or a solution. Where the last scope of opportunity? Okay, that question I have already answered. What kind of certification is more relevant for non-technical background? Either cloud practitioner you can begin with, but if you are looking for a job, a good job, then I would suggest that you go with a solution architect associate. What if the private cloud was broken by someone? How the company would manage that situation? When you say broken, what do you mean by that? The company, see, the private cloud would not be broken. See, what happened is it is an interface that you access. In the backend, there are data centers, and mostly any big cloud provider is not going to have one data center. They will have hundreds of data centers. So if one place is broken or some kind of an issue happens, you have other places, other data center, other locations. It's a massive global infrastructure. When you talk about AWS, Google Cloud, and all, they are having a very big, millions of servers are there in the one data center only, and there are hundreds of data centers. So you can imagine how big their architectures are, and that is spread it across the globe, across the world. Okay, so they have well backup plans, well redundancies. So in case of any kind of an outage, any kind of an issue, they have the backups for that. Okay. Um, all right. So few more questions I'll take it up, and then we will move to our cloud understandings. If it is hacked, you mean to say? Yeah, they have a lot of security measures. They have their teams. You may face an outage. I would not say that outages have never happened. Recently itself, a couple of years back, the AWS outage happened, which impacted almost many of the applications globally. But those were rectified very quickly. So that may happen anywhere. Hacking can happen even on the cloud or even in your data centers also, if it is the securities that are not properly implemented. All right. Now we'll take up the questions further later on, and let's try to understand that how do we work on the cloud. And I'm going to take up Amazon Web Services, which is the popular cloud provider, almost one of the biggest cloud providers. And first of all, we need to understand that here you can see, guys, I believe everyone can view my screen. Let me share it again. Okay, just give me a minute. Just allow me a minute. So guys, whenever you work on the cloud, you need to understand the infrastructure of the cloud. So whenever you work on the cloud, you need to understand the global infrastructure of the cloud. And this is basically how the AWS looks like. As I mentioned that you have to work on the cloud in the form of services only. You need to understand the services. How their backend infrastructure is, that is something which we are not bothered, which is the cloud's responsibility. So we have to understand that how we work on this interface for running our solutions and the projects. That is what we need to learn. A basic of global infrastructure of an AWS would be required to understand that. So every cloud has its own kind of resources, own kind of a global infrastructure. If I do a comparison between AWS, Azure, and Google Cloud, what I have observed is that since AWS pioneered this platform, AWS is more a region specific kind of a cloud. When I say region specific cloud means you have to select a region first. Let's say if you have to work in the US region, you have to select any of the location in the US where your workloads will be created. If you have to work in India, you may select Mumbai first or Hyderabad, and then you can get your projects or softwares servers get created. But if I do that comparison with Azure and with Google Cloud, so Azure and Google Cloud are a bit more centralized. Region dependency is not that much. You just start working on the service. Let's say if you have to create a server, you create a server, and then while creating a server, you select in which location you want to get it created. But that doesn't happen in the case of AWS. The first thing, mostly when you are going to work on the AWS, is you have to select a region. You have to select a location. So you can see that I have logged in into the AWS console, and I have selected a US region, Ohio. Now, what exactly a region is? You can see here, there are so many regions. Okay. I can select any of them. There is no restriction. If we are from India also, it is not, there is no restriction that I can't select a US region or a Europe region. I can select it. I can work on it. So region is a place where the AWS cloud has the zones, which are called as availability zones. And inside those availability zones, there is a cluster of data centers. And a data center is a place where there is a lot of servers and the infrastructure. So first of all, let me show you how does a data center looks like. We can find up some images from the internet itself. So let's say I click on data center. This is a single data center. This is how it looks like. This is the outer layer of the data center. And this is a small data center, Microsoft data center. So what it has a stack of servers. Here you can see all these servers are interconnected using the cabling. Likewise, there are a lot of racks. And this is a representation of one single data center. This is how it looks like. Okay, so here, this is the backside of a server racks. Now, in the cloud, there are cluster of data centers. There could be 3 data centers, 4 data centers, or many data centers. We don't know because the AWS doesn't disclose their locations and all because of the security reasons. And these cluster of data centers together form one zone, which is called as availability zone. Okay, so if you look into the AWS global infrastructure from the AWS site, let me open it up again. So primarily you need to understand region, availability zones, data center, you already got the concept. So data center, a cluster of data centers are called as availability zones, and multiple availability zones form one region. So how many regions you have in the AWS? 37 regions. Okay. I am using a free tier account of an AWS, so you will not be able to select all those 37 regions. Somewhere around 16 regions you can select. Rest of it, you have to upgrade your account. Now it doesn't mean, let's say if I have to select a Mumbai region, I selected a Mumbai region here. It will refresh. And then at the top right, you will see that it will show you the Mumbai region. Now, whatever I create on it, on this platform, it will be created in one of the data center within the Mumbai region. So Mumbai region doesn't mean that your data centers, your zones are in the Mumbai location. It means it's the nearby location for which the name is given as Mumbai. Ideally, the technical name is AP South 1, AP-South 1. So nearby to that location, there will be availability zones. In Mumbai region, we have 3 zones or 3 availability zones. Each zone will have cluster of data centers. All of them are interconnected using AWS internal private network. It is up to us which zone we want to work on. Okay. Now, what are the criteria of selecting of the region? Let's say, why should I select Mumbai? Why not Ohio? Why not California? Why not Oregon? Why Mumbai only? So what do you think? Because when you work on the AWS, it is necessary that you have to select a region first. You have to select a location first. Okay. If AWS is regional, how difficult is to share data across organizations globally? Not that difficult. And we have to understand the concept of networking on the AWS cloud, which we can understand with the help of VPC, virtual private cloud. And there are also a lot of interconnectivities that has happened where we can transfer the data at a very low latency between different regions. But it is more a kind of a distributed cloud because we have to select it from a region specific. I think that is something which was taken by other clouds and they try to make it more centralized. Obviously, there is a competition, and but what I feel is when I work on the AWS, I find it very good, very much organized and premium. And a lot of things means anything which is directly not available, we can customize and get it done very quickly. So there are around 37 regions. In that 37 regions, there are 117 availability zones. Each region must have at least two zones for the redundancy. Some regions have more than two, more than three zones also. Let's say this region, North Virginia, US East 1, it has 6 availability zones. And this is the default region of the AWS because when the AWS was launched, during that time, there was only one region, and that was this. And it is one of the cheapest regions also. Guys, it is not that whatever region that you're going to select, the cost and the pricing is going to be same. It is absolutely based on the location. We have observed that US regions are the cheapest one. Okay. Mumbai is not that expensive, somewhere around 10-20% expensive as compared to the US regions. Singapore is expensive, Sydney is expensive, Europe regions are also expensive. So accordingly, you have to look into the pricing and you have to select the region. So one factor of selection of the region is the pricing, the costing. The second factor is the latency. How quickly you can reach to that region or a location from the network. Okay. Let's say, for example, we are going to deploy a website on the cloud, and our website users are mostly going to be from India. Then why would I select an Ohio server or any other server, any other region to host a server there? I would prefer to host my website in a Mumbai server only or a Mumbai region server only, because this way the users would be able to open up the website quickly. It will improve the performance of my website only. Okay. So latency is an important factor, but these latencies are not calculated based on seeing the location distance. There are ways that you can calculate. So one of the tool that you can look for is Cloud Ping Info. And then there are other tools also. You can search it on the internet. This is a tool which is not invented by AWS or not. It's not a proprietorship of an AWS. It is developed by some kind of a developer only. And what it happens is, what it does is it creates a broadcast, HTTP ping broadcast to all the regions and wait for the response. And based on the response, it calculates the latency. Here you can see. So from my network, from my internet connection, the HTTP ping broadcast message went, and here it got me the latency calculation. So it says that if from my network, US regions are going to give me somewhere around 250 milliseconds of time to respond. And then if I take up Mumbai, how much it is? As of now, 62 milliseconds. Hyderabad, 85 milliseconds. So if the latency is a factor, then I would definitely prefer Mumbai or Hyderabad because it is very less. Quickly my websites are going to be opened. And again, it depends on the user base, from where exactly the users are going to come. We have to calculate an average latency. Every time it is not going to be same. So this time if I ping it, you can see Mumbai is now offering me around 50 milliseconds and Hyderabad is offering me around 46 milliseconds. So earlier Hyderabad was greater than Mumbai, but now it has changed. So we have to calculate the average latency. So that also becomes another factor for the selection of the region. Is it clear? Okay. Then there are other factors like some services are not available in all the regions. In US regions, you will find more services. In Mumbai region, less services. Then compliances comes up. There are laws, government laws. So accordingly, you have to follow and select the location and the region. But the Basic thing is that whenever you start working on the AWS, the first thing that you need to do is the selection of the region only. So I have already selected Mumbai AP South 1. Now the next thing we need to understand is what are the ways we can work on the AWS. So one way is I can use a AWS as a graphical user interface, the one that you are seeing on the screen. It's a UI, a web UI. This is the widely used way of accessing the AWS. Okay. And then if we want more advanced functionalities, then we have a CLI, a command line interface. So here you can see there is an embedded CLI, which is called as Cloud Shell. Okay, so I just have to click on it and you will see that it will open up a shell. It requires Python syntax. So if you have the understanding of Python, it will be easier for you to run it. Otherwise, there is a well documented commands that you can put it up. You just need to do the practices and you should be able to work on the CLI part of it as well. Then in case if you do not want to use a inbuilt CLI, then you can download the CLI also. Okay. How I have already downloaded the CLI. How you can download is you just have to search for AWS Cloud CLI, download, okay, and click on this particular link. And based on your laptop, let's say if you're using a Windows laptop, you select Windows, likewise Apple, Linux, and on Windows, you click on it and you download this CLI MSI on your laptops and then execute it or install it. Afterwards, what you need to do is once it is installed, you go to your drive, the C drive, and look for the program files. So go to the C drive, and here in the program files, you will see that there will be an Amazon folder that would be created. Okay, so just click on Amazon folder and you will see AWS CLI v2 that is installed. So that means it is installed on your system. And then how to configure it? You just have to open up a command prompt. PowerShell also you can open it up. Search for the CMD, the command prompt. Once it opens, let's wait for it. And then you just need to type a command, which is AWS space configure. Okay. So you can type AWS space configure. Where is that? It's not open yet. Let's wait for it. Meanwhile, I'll take up some questions in between if there are any. Yeah, I think it is open now. It's taking some time. All right. Here you go. Multiple windows. All right. So here what you need to do is you just need to type AWS space configure and it will ask you for the keys. It doesn't ask you for the username and the password. The username and the password is needed when you have to log in into the user interface, the graphical user interface. Okay. So let's wait for the keys. And once it asks you for the keys, it is going to, you just have to provide two keys. One is the access key and the other one is the secret access key. So how do you find those keys? You have to go to your AWS account and at the top right side, you just click on the account name, and here click on the security credentials. Okay. And from these security credentials, you should be able to generate the new keys. If they are already existing, you can use them. Okay, so it will open up another service which is called as IAM, Identity Access Management. And here in the Identity Access Management, you will get an option of working on the getting the keys, which are the access keys and the secret access keys. Here you can see. All right. So how these keys are created? These are all account specific keys. Ensure that these keys are placed in a secure folders, because if anyone gets in the access of these keys, they should be able to log in into the CLI of your AWS account. So I'm just going to show you how these keys are created. I'm just going to deactivate this one and then delete it. Let's say this is the key. Right, copy, paste, delete it. And then I'm just going to create a new key. So I'll just click on create access key. Understand that. Click on create access key. And one time you are able to view the secret access key, but next time this would be encrypted. So make sure that you download this in the CSV format. Okay. So I'm just going to copy the access key to the clipboard and going to paste it here. Then it asks us for the secret access key. So I'll just copy that and paste it. Parallelly, I'm going to download this CSV file as well. So I just download the CSV file. All right, that's fine. It will save on my system. And then the next thing is it asks us in which region you want to work. So we just wanted to work in the AP South one, that is Mumbai. Output format, you will keep it none. Generally, it is a default output in the JSON format only. And here you go. The AWS CLI is configured on the command prompt. And now you can run the commands, the AWS Python commands. If you want to see what is the version that is configured, so you just type AWS dash dash version, and you should be able to see that it's an AWS CLI with the specific Python version that is running. So let's wait for the output. Here you can see AWS CLI 2.9 running on Python 3.9. So that's how you can configure the CLI, and you can work it on the command prompt. Whatever the commands that you're going to add here in the command prompt, the output is going to reflect in the command prompt also, and even you can see it on the console as well. Uh, these are the two most popular ways to work on the AWS, and then there are other ways like you can get the SDKs, which are software development kits, primarily used by the developers. You can even access the AWS from the APIs as well. All right. Now, quickly, what we are going to do is we are going to launch one instance, a server, and then we are going to see that how we can connect to that server. We'll try to host a simple application also on that server. And that is going to be a basic HTML and the HTTP application. And then afterwards, we'll take up the question and answers, the Q&A. So guys, when you have to work on a particular service, if you need to know the name of that service, so I'm going to create a virtual machine, which can be created from a service that is called as EC2. EC2 stands for Elastic Cloud Compute, and it is a service which lies in the category of infrastructure as a services. Now, nowhere on the cloud, there will be written that it is an IaaS service or a PaaS service. You can get it from the documentation, or by experience, you'll get to know that in which category that service lies. So let's say when I open up the EC2 dashboard, it will open up the EC2 management console. And here, uh, the AWS has used a lot of their own kind of a naming conventions. Uh, they call virtual machine as instances, okay, which are generally a VMs only. So we have to go to the instances. Okay, it has refreshed now. Let's try to disconnect the extra links. And here we have to click on launch the instance. Launch instance means launching a virtual machine only. Now the next thing is it will give us a form, a template. We have to fill up the template and then we have to quickly run a virtual machine. Sometimes it may take time. It depends on the network bandwidth and which region that you're going to use as well. Since we are conducting a session and a lot of links are open. Let's say we have to create a number of instance one, and I put a name of the instance as my web server. And then there are a few more details that we want to add it up. Now we are going to tell AWS that what type of an operating system we want. So we want a Linux. We'll go with Amazon's Linux. That is fine. So this will ensure that the Linux operating system is installed on our server. What type of a server it is going to be? One CPU, 1 GB RAM is free tier. Free tier means that it is free of cost for some duration. So we'll keep it as it is. And then it says key pair. Key pair is required for logging into your instances in a more secure way. But Linux gives us an option that we can proceed without a key pair as well. So right now I'm just going to proceed without a key pair only. Network settings will keep everything default as of now, no changes. And in firewall, we will ensure that SSH traffic is open. And then since we are going to host a simple web application, so we'll ensure that HTTP traffic is also available on the internet so that we will be able to access our web server. Storage, the hard disk, 8 gigabytes is sufficient for Linux, and that is what we are going to go with. That's it. We are just going to click on launch instance, and you will see that how quickly we are able to get one virtual machine created as well. Just by a click of a button, by selecting up a form, in within a half minute, I am able to get a virtual server, and that too with the proper operating system installed, proper networking defined. We'll get a public IP address, we'll get a private IP address, likewise. Let's wait for it. Here you can see the instance is created. We got the instance ID. This is auto generated by the AWS. Either you can click on it, otherwise you go to the instances. And here on the dashboard, you will find that what all instances are running. So this is the one that is being initiated, web server, which is initializing. Linux based VMs are quite fast and you should be able to connect to them very quickly. Now, one of the easiest way to connect to the Linux instances, you select it, your virtual machine, go to the connect option. And here the default username is EC2-user only, and just click on connect. It will open up the SSH console. Pop-up blocked. Okay. Always allow. Connect. Let's see if we are able to connect now or not. Yes, now it is connected. So it will open up another link where we will be able to access the instance console. No need for the authentication because we are opening it up from the web UI. Already authentication has been done. No need for the username and the password. And here quickly, we should be able to connect to our Linux instance as well. Let's wait till it reflects. Okay, so here you go. Connected to the Linux instance. Now, what I'm going to do on this server is I'm just going to host a simple application, kind of a simple front end web page, which is going to be an HTML application. And for that, since it's a virtual machine that is installed, which is having a basic or a raw Linux operating system, and in order to host an HTML application, we need to install Apache, the HTTPD packages on it. Now, if those who are having a basic Linux understanding, they should be able to get it quickly. Otherwise, I'll be using only 4 to 5 commands, and you will see that we should be able to host our web page quickly on this server. Guys, this EC2-user on the Linux is a very basic user. It does not have the privileges much. So if we have to run any command using this user, we have to use sudo as a prefix before every command. Otherwise, what we can do, if we have a root access which has got the highest permissions, we can move to the root user, and the command is sudo space su. Su stands for super user. So just type a command sudo space su, and here you can see that it changes from EC2-user to root user. Now I don't have to use sudo as a prefix before every command. The next thing that I'm going to do is I'm going to install a simple, I'm going to install the HTTPD packages on the server by running a command yum install HTTPD. Now yum is an internet repository on the internet. This Linux server is going to access the yum repository and get the HTTPD packages from that repository and install it on this server. That is what this command means. And we need to ensure that this server should have the internet access, which already it has. So I'm just going to install the Apache, the HTTPD packages. Let's wait for it. All right. So we'll just, we'll do that again. Type Y. It's done. And then once the Apache is installed, it will create an HTML directory. So we are just going to change the directory with the command cd. Cd stands for changing the directory to var www html. This is the path. And the directories in the Linux has the files. So I'm just moved to the HTML directory. Here you can see from EC2-user, I just moved to the HTML directory. And then inside this HTML directory, I'm just going to create one simple index.html file. How I can create it? Either I can use nano as a file editor or I can use vi also. So I'll just use nano as a command and I'll put a file name. Before that, you should see that whether this HTML directory is empty or does it have, means it has some kind of a file also. You can type ls command, list all the files in the directory. It returns nothing. It's a blank directory. And then I'm just going to write nano index.html. We are just going to create a new file index.html with the file editor nano. And when I execute this command, it opens up the index.html file. Here you can see that as well. Now this is a blank file. We are going to add the HTML tags. We are not going to write it. So we'll get it from the internet. So there is one website that is called Best HTML Codes. And this is for the knowledge purpose. You just need to understand that how you can use these servers. And I can find any of the HTML tags. Let's say generic survey form. I open it up and it would give me a code. So I just copy the entire code and I'll go back to my index.html file. And here I'm just going to paste it. Oh, it doesn't copy. It is copying the key only. Let me do that again. Copy it, and then paste it. Yes, it is done. Now to exit from this file, here you can see Control and X we have to press to exit. So I'm just going to press Control and X together, press Y to save this file and press the Enter key. So I exit from the file editor. And if I do ls, I can see index.html file available. Now the final thing is I just need to restart the HTTPD services to make this active. So I'll just type service httpd restart. That's it. My web page is posted. And in order to test that, since we have already opened the HTTP ports on the firewall, so I should be able to view that web page as well. So I'm just going to copy the public IP of my instance. Let's wait for it. All right, so let's wait for the instance to reflect. And then once we get the public IP, we just have to paste that on the browser. This is the public IP. You can copy the public DNS also. Both ways it is fine. And when you put it on the browser and enter it, you should be able to see the web page. This is a survey form. This is coming from the instance that we have used for hosting the web page, this survey form. It is available for everyone. So I'm just going to paste this link, this IP address on the chat, and you guys can also paste this on the browser and see whether you are able to open up this web page or not, because it is open for entire internet. So it's a kind of a public deployment that we have done on the AWS cloud. Just see, you should be able to view it as well. All right, guys. So that was the usage in a real-time sense that you can do that with the AWS. And some questions like when should we use public, private, or hybrid cloud? Give us examples to understand. This was a public cloud deployment that we did. We hosted a website, a web front page, accessible by everyone, no restriction. The private cloud deployment is going to be, let's say, if I create a database, I will restrict the internet access so that no one should be able to access it from the internet. Hybrid cloud is when I integrate my website with the backend database to make it an entire solution. Okay. Any drawbacks on such a model? Which kind of a model, if you can name it? For practice, can we create an account as a guest user or have to pay for it? No, you can easily create an account on the AWS as a guest user. Make sure that you select a free tier account. And the second thing is you need to have a credit or a debit card, which is going to be a Visa or an Amex kind of a credit card or a debit card. The AWS is not going to charge your card on a monthly basis. They will just charge 2 rupee from your account at the time of account creation, which is also refunded. It is just for your authentication. And once you are authenticated, then you can start using the AWS services. Make sure, because not all the services are free of cost. Free tier account doesn't mean that everything is free of cost. You need to know that which services are free till what time period, which services are chargeable, and that is something which you should be knowing. Otherwise, there will be extra charges. But that is something you can ensure is that the AWS is not going to charge from your card that was provided while creating the account. You need to make a payment separately at the end of the month. You can select any of the card. You can use a net banking also. Okay. Which platform is better among all, AWS, Azure, or Google Cloud as per market? See, that's a very tricky question. Each and every platform is good. It has its own USPs, but I find AWS a very good, very well structured cloud, but it is more distributed. Microsoft Azure is very good in for Microsoft services. It has a lot of subscriptions also, a lot of services as well. Google Cloud is very good for the PaaS services, likewise. How do we know the usage for free account? Free tier account doesn't mean that everything is free of cost. Free tier account means that you will not get a support from the AWS. You will not be able to talk to the AWS engineers for your help. Free tier account only means that there are some services which are under the free category, and that too only for 12 months duration. Okay. And with whatever the services that are free tier, whenever you start selecting and creating it, you should be notified. For example, when you launch a new instance here, let me show you. Let me share my screen quickly. Okay, so here you can see that whenever you launch an instance, wherever it is free tier, it will be mentioned. Okay. So that is something which you need to study, and you need to know that which one is going to be the one that I have created. It was absolutely a free tier. So let's say when you click on launch instance here, let me take other questions till then. All right. So let me refresh it. So whenever you create an instance, let's say if you're going to select an AMI, it will be written whether it is free tier. Whenever you're going to select a type of an instance, it will be written that it is free of cost. Let's say T2.micro, for example. It is always free of cost for 750 hours duration. But that again has a limitation, because it is not that you can create 10 servers, all of them will be free of cost. Only one server you can create it. So you have to read properly, you have to understand what all services lies under the free tier category. Again, I am reiterating, free tier account doesn't mean that I can work on the AWS on any service and I would not be charged. No, there are services which will be charged, even in the EC2 also. There are some services which are under the free tier category, and that is something which we need to understand from the practice or from the training perspective. All right, guys. Any other questions do we have? So, guys, if you are interested, you can basically go through my Udemy course also. So, I'll just give you the link for that. Meanwhile, so in that Udemy course, I have added up all my modules related to AWS, and that would give you a perfect understanding to work on essential services of the AWS cloud as well. So meanwhile, I'll get the link and share it across with you. Preeti, over to you if you want to share something with the participants.
Yeah, actually, we have one session feedback form which I'm launching, and I would like to request everyone, guys, please do fill it out. If you have any suggestion how we can make our sessions better, anything, please mention that also. It will not take more than a minute to fill it out. It is like just 5 questions are there. And if you have any questions, guys, please write it down in a Q&A tab. Most of the questions like you have answered already. Okay. So, like I have one
Yes,
question
yes.
from my end. It's like any piece of advice you would like to give to the mostly to the youngsters who are going to enter this industry.
See, it's a very promising thing because any this is just a platform, and this platform can support almost all the technologies, be it from data analytics, data sciences. If you want to run even Python also, if you want to run coding also, if you are from an infrastructure background, from a networking background, or if you want to understand artificial intelligence, machine learning, mostly these things or these technologies are run on the cloud. And when we talk about the cloud, primarily these are the three main cloud providers like AWS, Azure, and Google Cloud. When you search for the jobs, you will find that mostly the companies are looking for these three main platforms, primarily AWS. And let's say if you know about the AWS, it becomes easier for you to learn the Azure. And it is not that people who know AWS, they cannot switch over to Azure or they cannot apply for the Azure cloud. Companies definitely prefer them because they have the understanding of the cloud. And I would advise the freshers or youngsters that they should start investing and understand about this platform, because that gives you the enormous opportunities. There are so many fields everywhere these days. the cloud computing is used. And once you understand this platform, understanding the other technologies also becomes very easier, and you can explore a lot of additional things that would definitely add an very much advantage in your career. All right, guys. So I have shared the link with you guys. If you are and if you want, I would be creating a new coupon code as well. You can go ahead and purchase our courses from the Udemy, and this is something our website that you can actually go through that as well. All right,
Uh,
over to you, Preeti. Yeah.
Ravi is asking, do you have a playlist for AZ204 as I am from MS Tech Stack?
AZ204, we do not have a recorded course as Udemy. We have our recorded sessions of just like this session only. But we are planning to launch AZ204 as well quickly. Once we do that, we will put it on our website and you can check that. We will share it with Shine as well.
Yes, and for that you guys can follow us and Akhil also.
Yes.
Yeah. Okay, so I think like we are done with all the questions and everything. And thank you very much, Akhil, for delivering such an insightful and engaging
Thank you.
session.
Thank you.
It
Thanks
was
for having me. I thanks Shine to have me on the platform as well. Yeah.
Thank you very much. It was a pleasure to have you with us today, and a big thank to the everyone who have joined us. We truly appreciate your time and participation. The recordings of this session will be available on our YouTube and LinkedIn page, so feel free to revisit anytime. And still, if you have any question, please feel free to reach out to us, or you can directly connect to Akhil. So yeah, that's it for the session. Looking forward to see you all in our upcoming session. Have a great day. And once again, thank you very much.
Thanks,
Thank you
guys.
very much,
Thanks for
Akhil.
attending. Thanks for your time. Hope it
Thank
was an
you.
insightful
Bye
session.
bye.
Bye. Take
Bye
care.
everyone.